Now we're going to talk about volume of three different kinds of shapes: pyramids, cones, and spheres. Now the good news is with the formulas, if you know the formulas, these are pretty straightforward. It's just a matter of remembering which formula goes with which one. So a pyramid has 1/3 the volume of a prism with the same base and height. One important thing is you got to remember the height of a pyramid is the perpendicular distance. Is the perpendicular distance from the vertex, which is the point at the top of the pyramid, to the base. So if you were to draw a vertical line straight down from the vertex, the point on the pyramid, to the base, that is where you get the height. So as the sentence says, the volume of a pyramid is 1/3 the base of a prism, which is capital B, area of the base, times the height of the 3D shape. So let's practice two of these. Find the volume of the pyramid, round to the nearest tenth if necessary. Now this one does not look like a pyramid in the sense that the ones in Egypt look like. This is a pyramid still, but it's maybe hard to tell, but these are right angles right here. This forms almost the peak, or the point of it is at this corner, not like in the middle of all of them. So we do volume equals 1/3 area of the base times the height. Now this base is triangular. So the area of a triangle, to get the area of the base, we do 1/2 times the base times the height. Now this is the height of the triangle that's the base. This h out here is the height of the pyramid. So as I look at this, I tend to think of it more like this, where the base of the pyramid is this length, which is 6 centimeters. The height of the triangle is this, which is 8 centimeters. So the way I would plug this in personally is I'd say 1/3 times 1/2 times the base of the triangle, 6, times the height of the triangle, 8, times the height of the whole pyramid, which is 5. So then you multiply all those together, and you end up with 40 cubic centimeters. Now, number 2 does not give us a picture, but that's all right. It says find the volume of a pyramid with base area of 90 square feet. So it's important to read this carefully. This is not the lowercase b base like this was for the triangle. This is the uppercase B base. It's the area of the base of the pyramid. So that means capital B equals 90. And this is the height of the pyramid, which is 12. So this one is actually quicker than it may first appear, because they've given us the two things we need. We need the area of the base and the height, and that's exactly what they gave us. So we plug in 90 for capital B, because it's the area of the base, 12 for the height. We get a total of 360 cubic feet. Given that we've already done prisms, which use V equals capital BH, this one isn't a whole lot harder. It's just a matter of remembering to do 1/3 of that amount. So that's pyramids. Now let's look at cones. So the volume of a cone. The volume of a cone with radius r is 1/3 the area of the base pi r squared times the height h. So this actually means it's 1/3 of the area of a cylinder, because a cylinder was identical to this formula except didn't have the 1/3. It was just pi r squared h. So just like the pyramid is 1/3 of a prism, the cone is 1/3 of a cylinder. So the two things we need when we need to solve for this to find the volume are the radius and the height. So find the volume of the cone, round to the nearest tenth. So V equals 1/3 pi. You know, r, the radius, they gave that to us right here. It's a 5. So 5 squared times the height, which is right here, it is 7. So then you can type all that in your calculator. Make sure you use the actual pi button. Don't use 3.14. Use the actual pi button. But rounded to the nearest tenth, you get 183.3 cubic millimeters. The only thing that may be tricky about this is the same thing that happens with almost all the circles. There may be times where they give you the diameter instead of the radius. If that happens, just remember you must divide that by 2 to get the radius. Like on this one, they could have said, oh, well, the diameter is 10 millimeters. And then you'd have to say, oh, that's the diameter, so I got to cut that in half and get the radius, which is 5. That's the only thing that can be tricky about these. Okay, that issue is the same with the sphere. We need the radius for this formula. There may be times where they give us the diameter instead, and when they do that, we'll just need to divide it by 2 so we know the radius and can plug that in. So the volume of the sphere is 4/3 pi r cubed. So what's cool about this formula is the only thing we need is the radius. So if they give us the radius, great. If they give us the diameter, there's just one extra step, and that's dividing by 2 to change the diameter to the radius. So we have v equals 4/3 pi, then our radius in this one is 8. So 4/3 pi times 8 cubed. And if you type that in, it's a bigger number than we've been getting, 2,144.7 cubic inches. So since I am allowing you to use your calculator, as long as you understand how to plug numbers into these formulas, I hope this is very straightforward for you.